Good morning to all. This is M. Visalakshi and Professor R. Sudha, Assistant Professor, Department of Electrical and Electronics Engineering in Tandai Periyar Government Institute of Technology. Welcome to e-learning class and today's video about the apparatus protection. Here we are going to see about the zones of protection. So basic concepts are already in previous video lecture. So here this zones of protection is mainly the region of power system which can be protected with the fault recognition and removal of minimum amount of equipment, and it is also divided into several zones which contains one or more components in power system with two circuit breakers, and this is need to overlap each other and to ensure the no paths system without protection. Here this circuit breaker inserted between the component of zone and the power system. When fault occurs within the boundary of zone, then the system acts to isolate or tripping the circuit breaker. It must overlap to prevent any system from being unprotected. So some of the type of protection are primary and backup protection. Coming to primary protection, it is the first line of defense and responsible to protect all the power system element from all type of fault, and it is also to ensure the fast and selective clearing of any fault within the boundary where zone can be protected. Even though some failures will be required in primary protection are current or voltage supply, DC tripping voltage, protective relay, circuit breakers. Backup protection, it is mainly when the primary protection fails, that time this primary backup protection is to be used, and it is mainly designed to be coordinated with the designing of primary protection. So this is the designing of backup protection. It is represented by the color coding of different transmission lines and protection systems. So this is my bus bar protection, and this is your generator protection, and this is your transmission line protection, feeder and transformer protection, and current transformer and protective transformer in protection schemes. So coming to the current transformer, mainly it is used to measure the current of high magnitude, and large alternating current cannot be sensed or passed through the normal ammeter and current coil of wattmeter, energy meter. It can be easily measured by the use of this type current transformer with a normal range of instruments. This is a device which consists of two windings called primary and secondary. Its energy transferring from one side to another with a change in level of current or voltages. Here this is a transformer having a primary coil of one or more turns of heavy cross section area. This bar carrying high current which acts as a primary, and this is connected in series with the line current carrying high value. Coming to the secondary of the transformer made of large number of turns having small cross section area. So here how it works, this current transformer, it is basically a step up transformer, means stepping up the voltage from primary to secondary. This current reduces from primary to secondary. So this or step down transformer means stepping down the current value from primary to secondary. So this can be represented by I1 by I2, comparing with the number of turns N2 by N1. So potential transformer. Potential transformer, it's a step down transformer with the accurate turns ratio. Here the high voltage or reduced in a fixed proportion for the measurement purpose with the help of potential transformer. This construction is mainly similar to your normal transformer, and this are a low power rating. windings. So here primary winding consists of large number of turns, while secondary less number of turns, usually rated to 110 voltage. So here primary is connected across this high voltage, which is represented in your circuit diagram, and this secondary is connected to the low range voltmeter coil. So one of the secondary is always grounded for safety purpose. As we all told, is basically of comparing with the normal transformer. So its ratio will be V1 by V2 or Vp by Vs will be equal to N1 by N2 or I2 by I1 or Is by Ip. So here coming to the bus bar protection line, in generating or substations form link between the incoming and outgoing circuits. If any fault occurs or damage, any disruption in supply, it will be automatically isolated. So the main purpose of this protection is to isolate switches or circuit breakers. Some of the bus bar protections are differential and fault bus protection. Coming to differential protection, different schemes with current entering and leaving the buses. When it is in normal condition without affecting the fault, sum of the current will be equal to 0. If any fault occurs, it upsets the balance and produce differential current to operate the relay. So here the circuit diagram representing the bus bar, which is fed by the generator and load to the second lines. And coming to current transformer in generator, which leads to line 1 and line 2 is connected in parallel. Here this relay is connected across the parallel connection. Coming to fault bus protection, it can be achieved by providing the metal barrier in each conductor called fault bus. This flow of fault current is to detect the fault and to determine the particular location where the fault occurs. So here this diagrammatic representation of fault bus means a metal supporting fault is earthed through the current transformer and relay is connected across the secondary of the current transformer. The main operation of this relay will trip all the breakers connected to the bus. Okay, and coming to the protection of line, it is mainly due to the greater length and exposure to the atmospheric condition. Main requirement of this protection of line is in short circuit, the circuit breaker closer to the fault will open and remaining will be in a closed protection position. If any fault fails to open, this backup protection to be provided by the adjacent of circuit breakers. Some of the methods of protection lines are they: time graded overcurrent protection, differential protection, distance protection. Coming to this time graded, many types are there: radial feeders, parallel feeder, ring main feeder. So in radial feeder, two different types means definite time relay and inverse time relay. So here in this method, during the fault, only circuit breakers are closed to the fault point, this to be tripped. If circuit breakers are closed to the fault point and it fails to trip, this circuit breaker just next to this breaker will breaks up this. Time graded. So time graded overprotection mainly refers to the overcurrent protection of electrical power transmission lines. So here this radial feeder mainly referring the power flow in one direction, which is from source to load. Okay, this can be easily protected by using either definite time or inverse time relays. So here this is represented by the operating time as well as your distance. So how much of time it takes for the given generating station to the substation 1, 2, 3, etc. And here this also a fault will be occurring. So here coming to the line protection, So total line will be divided into different selection, and each section is provided with the definite time relay. This relay nearest to the end of the line has minimum time setting, while time setting of other relay will be increased. Coming to the parallel feeders, this is mainly for maintaining the stability system. It is required to feed load from the source. So here this is done by the two or more than two parallel feeders. Okay, so here two or more parallel feeders are there, feeder 1 and feeder 2. This is your supply end and this is my receiving end connected with the bus bar and the load. So the direction represents, single line represents your direction, and this line represents your non-directions point. If any fault occurs in any feeder, only the particular fault feeders should be isolated from the system. Why? Because in order to maintain the continuity of the supply system from source to load. So if any fault occurs, a particular will be isolated and the remaining will continue their process from the source to end. Coming to ring main system protection, and this is mainly feeds with two feeders but in different path. Okay, so, and also it forms a loop, closed loop. So as we all seeing this diagram, which is your closed loop, starts from bus bar and runs through the load area, feeding and returning to the same. So this is the purpose of ring main system protection. So in this we have seen the different type of protections, primary and backup protection, and bus bar protection, and how the current and potential transformer works in this protective schemes, and different protection schemes are there, radial, ring main, parallel feeders, and these are all from source to load. So here when this is compared with the normal condition as well as the fault occurs in the power systems. Thank you for watching.